Okay. Hello everyone, very good evening. So let's wait for some more few minutes because still some students are yet to join. So we'll be starting the meet by 5. Okay. Hello everyone, very good evening. I'm Shalini here, the senior executive from Navars Edutech. So thank you for all for attending for the webinar regarding student satellite making program. So here firstly, I would really like to appreciate KRM Public School Management who always encourage students towards their courageous future in different aspects. So let me introduce about our organization where we are the one who are building a global space education platform. And nowadays we can confidently say that most of the children are excited to learn about space. So this program is all about the students at where the child can launch their own satellite by taking the observations and so on. So this is quite interesting, right? So here is a chance to do that. While going through, you will really understand about how the children participation will happen by making a satellite. And the most exciting part is that the winners will be a part to launch the satellite in Germany. So this is a very big opportunity for the students. So what we do is, as a company, we help the children to understand space through multiple online courses that we provide. We make the participation of NASO, which is International Olympiad, that you are aware of. And this year we had excellent participation of 50,000 plus students. We also help the students to participate in research programs, and the students who are in 9th, 10th and 11th will also have opportunity for internships, so that they can do some higher studies while they apply in some international colleges where they can get help from us. So the most interesting is that we also have excellent community page where the child can be a part of lot of education that students and teachers from side will have continuous communication, and it's like the space Instagram where you love it. So finally, let me introduce Mr. Priyadarshan sir. So he is having 5 years experience in astronomy and he is our astrophysician. So welcome Priyadarshan sir to continue the class.
Thank you, Shalini. Hi guys, hello everyone. How are you? I hope you're all doing great. And one more thing, Shalini, can you unshare the screen that? Yeah.
Yeah,
yes.
Sure, sir. Sure.
Yes. So yeah, today we are going to talk about StudentSat program. So we are going to today see what is a satellite, what are its uses, how do we design satellite, and what are the types of satellites and uses, because you are going to build a satellite, right? So this is the main agenda of this program, where we will give you exposure to build your own satellite. As you already know that at KRM school, we have our lab in the JJ block. And, this is a, very good opportunity for you to come and learn about the satellites, space, missions, and how the entire space industry works, how the science behind the, venture towards space works, and all those things, right? So today we are going to see one specific aspect about the satellite. So what is that one specific aspect about the satellite is that today we are going to see the satellite design. How do we design a satellite? Because you are going to build it, right, anyways. So you should know how to design a satellite, right? So today's topic is all about the designing of satellite. So this is also called as satellite designing, where you will be, where you will be learning about the design and the uses and the various other aspects. Give me a second, let me just share the screen. Yes, yeah. So today we are going to talk about what is a satellite, how can we design a satellite, and what are the mission requirements, and how we launch it. So we can launch it through rockets, we can launch it through balloon satellites. Some satellites are launched using high altitude, airplanes, right? And zeppelins. These are the balloon-like airplanes that you would have seen in the World War movies and all those. It's a huge airplane with a huge balloon in it. So many other ways. There are so many other ways to launch a satellite. So before that, let me ask you a question. What is a satellite? And what is the use of the satellite? See, we have a lot of astronomical space-based equipments, like we have telescope. We have various types of telescopes, from a very small telescope to a huge observatory grade telescopes. But there is one thing, that using this telescope, we can see the entire universe. We can see the stars, galaxies, we can see the nebula, we can see the structures in the galaxies, we even saw black holes, neutron stars. We can see so many things through the telescope. But there is one thing that we cannot do with the telescope. That is seeing our own Earth. So that is what satellite helps us to do. It helps us study our own Earth, our own ecosystem, our own way of how nature is, distributing its resources on Earth, how the water flows on Earth, the rivers, how we can map the entire territory just by taking a picture of India. We can mark the boundaries easily. It is called cartography. So satellites are used in that. Satellites are used in communication purposes. So say for example, like I think most of you might have watched FIFA, right? FIFA World Cup. So how it is broadcasted. So these broadcasts are here, very dependent on these satellites. So this is Qatar. This is where exactly where the FIFA happened, and exactly if you see, this is where the United States of America is. So how we transmitted this entire live of this FIFA World Cup to the other part of the earth with the help of satellite. There are satellites called geostationary satellites. They are communication satellites. They are kept at a certain altitude, like 36,000 kilometers. So whatever that we capture over here, we broadcast to this satellite. This satellite will broadcast to this satellite, and this satellite will broadcast to this satellite. And then it gets received on the other end in the United States of America. So they can see the goal that is scored in a very, real-time manner. In a very real-time manner, they can watch it. So not only that, satellites are used in various applications, like military purposes. There are satellites called remote sensing satellites that is used to see the, say for example, there is a natural calamity like flood happened, huge rainfall is happening, forest fire is happening. These users, we need an eye in the sky to see how far the damage is. So for that purpose, we are using these kinds of satellites. So what is a satellite? Satellite is an object that is in orbit with a planet, or else, in fact, moon. Okay, in fact, moon is a natural satellite. Any object that is revolving around any other celestial object, that is a satellite. It can be either a man-made satellite or it can be a natural satellite. Natural satellite, you already know, that is our moon. But man-made satellites are of various different types, and we have built so many man-made satellites. Almost 5,000 satellites are there right now in the orbit of Earth, giving us a lot more information that we need regarding various other things. It can be for communication purpose, it can be for disaster management, remote sensing, and it can be used for Earth observation satellites, where we see these pictures from Google Maps, right? These are all the things that are captured by Earth observation satellites. EOS, we call it, Earth observation satellite. So satellites has various uses and it benefits us. Without satellite, say for example, you have a Tata DTH is there, or else Sunnex DTH, Videocon DTH is there in your house. If you go to the terrace, so it directly communicates with the satellite. Whatever data is, whatever all the TV channels are sent to the satellite, and it gets beamed to the DTH, and through that we are watching the television, right? Without satellites in the modern day, it is very difficult to do our day-to-day work as well. But the first satellite was launched in 1950. The first satellite is called Sputnik, launched by Russia. And if you take India, India's first satellite, you already know, most of you, it's Aryabhatta, right? So we've launched these kinds of satellites. Now let's see how we can build a satellite. What are the things to consider before building a satellite? So the first thing when it comes to building a satellite is to define its purpose. Because based on its purpose only, we can design it. Based on the design only, we can attach hardware in it. And based on the hardware only, we can do the testing. Say, for example, right now, I need to observe certain region of the India-Pakistan border. I need to understand whether how troop movements are. Say, for example, you're in the army and you're the army officer and you want to know how the troop movement is in the India-Pakistan border. So whether are there any troops that are crossing, or else, how the troop is moving inside Pakistan and all those things, or else how the troops are moving the China border. Just to get an information, we are not going to launch an attack, just to get an information of how the troop movement is. So this is the purpose. So in order to see the true movement, what do we need? We need a very powerful camera. Okay, wonderful. So we've installed a camera. After, see, these are the hardwares. So based on the purpose, we define the hardware. And what else do we need? We need a high powerful antenna to send all the pictures and videos taken by antenna. And what do we need? Even more, we need solar panel to supply the energy, right? From the solar energy, creates electricity from the solar panel. Solar panel creates electricity. So we need a power source. What else do we need? We need radio communication. So most of the satellites, they are not built for one single purpose. They're built for multiple purposes. So since it is a military satellite, what we can do is we can add powerful antennas where we can give satellite phones to the soldiers. So even in the places where there is no mobile network, they can communicate through the satellite to tell us the real-time locations of where they are. They will not get lost in the jungle. They will not get lost in the places, unhospitable places. This is one of the purpose. Say, for example, now we need to test the weather. What are the things that we need to use? So that is so now our purpose is to find the weather monitoring satellites. So in this case, what we are going to build, what we need sensors. We need humidity sensor, we need temperature sensor, we need pressure sensor. And these sensors are called the payloads, or else the components or the hardwares. So based on the purpose, we select the hardwares. Using these hardwares, we create a design. We design the satellite in such a way that whether the huge areas needed to accommodate all these equipments, or we need only a small area to accommodate these equipments. And then once we completely built it, we defined the purpose, we designed it, and then we installed the hardware. Here comes the most important part, that is testing. Because after launching it, if something doesn't work, say for example, if a sensor is malfunctioning, you cannot send a mechanic or else an aerospace engineer to go there and take up a study and then repair it. You cannot send a mechanic to repair it, right? So in that case, what we can do is we will have to test the system. We will have to test every single component, whether it's working or not. One time, two times, three times, multiple times, we have to test under various circumstances. We'll test in a sub-zero condition, which is like very cold. We'll test in a very hot condition, because this satellite, when it goes behind the shadow of the Earth, the temperature is very, very low. So we have to test that scenario. When it is like directly in front of the sun, it'll get hot. We'll have to test that kind of scenario. So we'll have to test multiple scenarios to see whether that satellite is properly functioning or whether the design is properly working or not. If there is any problem, say for example, there is too much heat that is accumulated and satellite, one of the sensors failed, what we will do is we'll again come back to the drawing board to make a new design that will work. This is how this part is very, very important. It is always, when it comes to scientific manufacturing of scientific instruments, first we define the purpose. Based on the purpose, we design it. Based on the design, we select the hardware. After doing all this, we'll do the testing process. But now satellite comes in various sizes, right? So this is a huge satellite. This satellite is almost to the size of your car. It is almost 3 to 5 tons. Tons mean 1 ton is 1,000 kilograms. Maybe it's 5,000 kilograms. These satellites are mostly communication satellites, weather satellites. They are so big because it has lots and lots of equipments in it, like sensors, payloads, like cameras. Payloads are basically the components that are used to collect information. It can be weather information, it can be information like taking photos, it can be any information, right? It can be the information of how much water is accumulated in the cloud. Based on that, we can predict how much rain, it will pour on certain regions. And these kind of data can be gathered based on this. But can we build this much big satellite? No, we cannot, because if we build this, we need a very, very powerful rocket to send this satellite to space. So we might need PSLV, GSLV rockets to send it to space. But right now, the technology has advanced so much that we started making smaller satellites. They almost, obviously, the smaller satellites cannot completely, do all the functions of this bigger satellite. But we can select, we can make the smaller satellites only for specific missions. Say, for example, my mission requirement is only for 12 months or else 6 months. I can build a small satellite and it will function for 6 to 1 year. After that, this satellite will not function. But within that 1 year, we'll get a lot more valuable data. And the cost of production is also less. We will not litter on space. Like this satellite will not harm any other bigger satellites. If two bigger satellites are there, the chances of colliding at some point will be higher. So this, since it's a smaller satellite, it will deorbit and it will crash somewhere in the ocean safely without harming any other satellite or any other human being. Mostly it will get burnt before reaching the ocean. So this type of satellites are called CubeSats, and that is what we are going to build. We are going to build something called CubeSats. So these satellites are in the form of cube, as the name itself suggests. It is a CubeSat. So it will be like this. This is something what we call it as 1U CubeSat, which means 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter. All the sides. It's a CubeSat, and that is what we are going to build. Before that, let's see the uses of satellites. Be it a bigger satellite or else a smaller satellite. It is used in 3 different regions. We might be thinking it's only used in the cities and all those. No, even in the rural areas, it is often used. One is for broadcasting, like I said. Second is for communication, like I said, in the military and all those things. Even the internet that we are using, some of the internet that are like often comes from space. Say, for example, there is something called Starlink that actually, gets internet from the satellites that are above the Earth, that are orbiting. That is called Starlink, launched by SpaceX. And then we have disaster rescue. Say, for example, how we assess the floods. Say, for example, the Chennai flood, the Assam floods. When these Kedarnath floods, when it happened, we used these satellites to see how much damage has been dealt, how much area or square kilometer was damaged by this flood, and how many people were trapped in the terrace. We can see that, and we can send the army chopper to help them out. And then we also use it for tracking. So we can track our cars, and we also use our phones, right? GPS, right? These GPS, they have a chip inside the phone that communicates with the satellite to tell us the location. That is what we call it as tracking and navigation. Thirdly, there is something called maritime affairs, or else, air traffic. Right now, we are on the road. We have all the signals, like, red means you have to stop, green means you have to go, orange means you get ready to stop. But when it comes to ship traffic, or else the huge ships that are traveling the ocean and the traffic in the atmosphere, that is 2 airplanes, they should not collide, right? If it collides, it will be a disaster. So, and if you cannot put a signal in the atmosphere, you cannot suspend a balloon showing a red color signal, or else turn left, turn right to an airplane, right? You cannot do that. In that case, the satellite is very, very helpful. This satellite tracks the movement of all these ships and airplanes, tells the nearby airplane that this airplane is heading your direction. Kindly take right. Because it is having a bird's eye view of watching the airplanes that are flying. So using this, the airplane easily avoids the collision, and then they move in a different direction. Same goes with maritime affairs, like the ships and all those. So there are places called canals, Suez Canal, Panama Canal, Strait of Hormuz. these kind of places where the area is very, very small. Okay, so when they cross the small, narrow area, they should know that whether is there any other ship that is blocking the route in that others on the other side. If both the ships come in contact, they'll block both the ways, and neither of the ship can move in with the respective direction. So this is also used in maritime office. So the satellites uses are, countless. In fact, we are even using satellites to study the space. There are so many satellites, like the space telescopes. They are also a form of a satellite, because they also contain, this is basically a telescope hooked onto a huge satellite. We have Hubble Space Telescope, JSW, James Webb Space Telescope, and we have various such telescopes like we have Spectra telescopes and all those things, Spitzer telescope. So many other telescopes are there in space taking pictures of the galaxies. That picture only, that is the picture that we are seeing. So that is also a form of a satellite. So satellites uses are, like I said, it's countless, but it is very, 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 very important. Without satellite, we cannot perform day-to-day activities as flawlessly. They dominate most of our everyday activity and our works. Now, let's get on to the today's subject, that is CubeSats. This is what we are going to build. Your satellite is going to look like this. It is a 1U CubeSat. You might be asking, it's just a cube. What would be inside? That is exactly the next topic, is what are the components of CubeSat? So this CubeSat contains various components. Majorly, we are going to see 4 components. One is the onboard computer. It's like the brain of the satellite. Secondly, we have the power source, that is battery. That is the battery. Third, we have the communication systems. To send the data after receiving the information using the sensors, to send the data, we need communication. And then third, we have solar panels to charge the batteries. Say, for example, the satellite is going on the other side of the Earth, where the sun's light is obstructed by the Earth's shadow, or else the Earth itself. In that case, we need electricity that has to be stored in a different area, right? So that is stored in the battery until this satellite comes from the other side. We'll use this, the satellite will be using the electricity in this battery. Again, it will be charged. It keeps on going. And then we have something called magnetometer. This magnetometer helps us to tell the orientation of the satellite, whether satellite is fumbling, or else whether the satellite is traveling the straight line, or else it is tilted. So it uses the orientation of the satellite. So majorly, when you take any satellite for that matter, you will be having onboard computer or else flight computer. We call this flight computer or else onboard computer. It also has the memory also. It will have a memory, a memory storage device. We call it storage device. Like, it might have a hard disk or else a memory card to get all the data in it. And it will also have various other instruments like the temperature sensor, humidity sensor, to check whether the satellite is working properly or not. It gets all the information from all the components. And the bigger satellites will also have something called thrusters, because the satellite has to be adjusted all the time to keep them in the orbit. So these thrusters are smaller rockets that are used to keep the satellite in a specified orbit always. So it's a very small, a rocket that fires every now and then to keep the satellite in the orbit. This is the these are the major components of a satellite. Okay, so this is the case one. Now, let's define the purpose of our CubeSat. Our purpose of the CubeSat is to collect the atmospheric data. From that data, you'll have to infer the results. What kind of results, at what at what altitude these kind of temperatures exist, at what altitude these kind of atmospheric pressure exists, at what altitude this much amount of humidity is present. So this is what you will be getting. It is basically like a remote sensing satellite or else an observation satellite. Okay. So that is what we are going to build it. And you can design your own satellite in a tool called Tinkercad. So this is something what we call it as Tinkercad. Let me just show you how to build this Tinkercad. Okay. So just give me a second. Let me open the Tinkercad software and I'll show you how you can build your own, design your own satellite. So here comes the Tinkercad software. Now what I'm going to do is I'm going to log in. I'm going to log in using my Google ID. I guess, yes, you can use your Google ID and it's very, very easy. And I'll select India, my date of birth, somewhere, yes. Then it asks for a password, that's it. Okay, it's very simple. Then let me just show you how it can be done without the help of this software. Let me just give me a second. Let me just open it, open another tab, and we'll use Tinkercad. Yes. So once you enter all the details and register, you will get a screen like this. You will get a screen like this, and in the screen, just click on your name, go to new design, and then 3D design. And then once you click the 3D design, you will get a design platform like this. You can get a design platform like this. From here, you can start designing your own satellite. Like you can, you can increase the size and you can move it. So here comes a small cube that I built it. So let me just make it as a proper cube. Now, after building a cube, this is the satellite cube or else the CubeSat bus. Now I need a solar panel, right? So I might need a solar panel. So how I'm going to build it? I'm going to change the color of it and I'm going to build the solar panel. So now I build the solar panel and I can also install, what else do I need? I need a battery. So I can install a battery like this. I can put the battery inside and I can do a lot more things. Not only that, if I go back after doing this, what you can also do is you can go back to new design and you can click the circuit and you can start using the circuit. So you will be having a breadboard in our kit also, students at kit also. We have a breadboard and we have few resistors, we have switches and we have batteries. So you can start building the satellite here itself and you can test it before designing it in the real time. You can test it here, everything, every bit of, you have a photoresistor, you have various sensors, temperature sensor, humidity sensor, motor is there. Everything is present over here. So I can connect the line negative to the negative terminal, positive to the positive terminal. So I can connect it here and I can connect an LED to one terminal and I can connect, I think I can connect this to this and you can see it will start functioning. So this is very, very easy to build it. It's extremely easy to build this satellite virtually before going on and building the actual satellite. So this is one of the methods that you can employ to build your own satellite very easily. And finally, let's get into the StudentSat program. In this program only, we are going to build the satellite with the help of the kits that we have provided and also the course that we have given to you. So from this, you will get a set of equipments, like you will get a satellite bus, you will get all the instruments that are there inside it. And using these instruments, what you can do is you can build your own satellite. It will have all the instruments that are necessary to build a satellite inside this. And it is a lot more fun to build these satellites. And once you build it, you can connect it to your smartphone. You get all the data from the sensors that we have provided, and you can do it. And also, for every bit of the construction, we have videos. Once you start the program, you will have a video along with the kit. So you will have a pre-recorded classes, and the links will also be provided to you. And once you register it, you have to go through the course. So we have 4 modules. In that 4 modules, you'll be learning so many things about what is a sensor, what is a breadboard, what is a flight computer, what is a power module, what is the DHT sensor. I mean the temperature humidity sensor. You'll be learning about what is a you will be learning about different sensors like power modules and solar panels, how it works, jumper cables, and you will also be learning about the flight computer that has built-in Bluetooth and Wi-Fi enabled, how you can use your app, how you can download an app, get all the data from this satellite to your smartphone to see the data real time, and you can test it in multiple scenarios. Like you can test it in a dark room to see how much light intensity is there. You can test it in a bright sun, under a bright sunlight. You can see how much light intensity is there. So you can test this under various circumstances to get the data, and then we will tell you what to do with the data. Because after getting the data, you need to have a tangible results, right? That results, how we can get results, how you can interpret the data, understand that, analyze the data, and write a conclusion or else a report. So you'll have challenges in between. You'll have quiz, you'll have descriptive type answers, and then you will have a few more things. Once you've done all this, once you've completed all that, you will have another contest where you'll be writing an essay. So there are 3 levels of challenges. Level 1, like I said, quiz. Level 2, it would be descriptive. Level 3, it is going to be an essay or else a report. So once you complete all this challenge and you build your own satellite, after building your own satellite, you will be selected. Once you emerge as the top 3 contestant or top 3 participant, you will be considered as a winner, top 3 winners, and you will be taken to Germany, where you can see the satellite that you built will be launched in front of your eyes. Where the jumper cable wires and all those things, it will be converted into PCB boards. It will be taken from you, and it will be as a PCB board, like a chip from your design that you have built. Okay, and then it will go to the space, it will get all the data, and it will come back, and you can have that satellite in your house, that satellite that has gone to space, that you can keep it in your house. And you can do a lot more experiments beyond that. If you want, you can add camera, you can add multiple sensors, LEDs if you want. Maybe you can turn it into a lamp, a fancy satellite lamp, and you can do a lot more wonderful things. Now let me show you how this satellite is going to look like. Give me a second. So let me just start the video of what are all the things that you will be receiving.
Okay, everyone, let's understand how to assemble the entire bus. For this,
now this is the satellite bus. We call it the satellite bus. Okay. So this is a structure that is used to hold all the components inside. All the components inside. Once you start building it using the screws provided and the bolts that that are provided. Now you have to tighten it. Now your satellite bus, or else the house for the satellite, we call it housing, where every instrument and the equipments and sensors will be kept. Now it is completely ready. Now it is completely ready. Now you are going to screw it, tighten it from all the sides, and then you will be installing something called the battery. First, you'll install the battery underneath it, and then you will be installing a power module, and then you will be installing the payload bay. This is a small tray on which you will install all the components that you have built. So after installing the payload bay, it is very, very simple, right? Next up, so we'll screw it up, we'll tighten it up, and then we'll be mounting the electronics. So this electronics, this entire part, this is something that you will be building. This is the satellite itself. I mean, the main satellite itself. This is the payload. It has a flight computer. It has a power module. It has various sensors, DHT sensor, LiDAR sensor, and barometric pressure sensor, BMP 180 sensor. All the sensors, jumper cables are there. Everything is housed inside this. Where to connect these, in which area you have to use it, everything will be shown in the LMS learning management platform. And what you will be doing is, after completely building it, you will be installing this on the payload bay. You'll be mounting this on the payload bay, and you will either charge it through this USB port, or else you can charge it through solar panel. Now we are connecting the solar panel, and see, and it'll have a tape, a strong duct tape, not a duct tape, it's a 3M strong tape. It will not come out that easily. So you will be installing this on the sides, to get a proper sunlight when it goes to space. And now your satellite is done. Now the final thing is, we will be connecting the battery, the power, to the satellite to see whether it is working or not. See, now it starts working. Now you can connect to your smartphone and you collect all the data, and you follow the steps, and then you go through the challenges. And if you clear 3 levels of challenges, you will be selected as a winner, and then this satellite will be collected from you. Along with you, you will also be coming to Germany, where you can witness this satellite. Will be witness the satellite getting launched in a weather balloon that goes up to the altitude of 33 to 38 kilometers, and it will get all the near space data, and it will come back. And with that data, you can write your own report also based on the observation. This is the student SAT program, and I hope it's very interesting, right? And I hope you found it useful. And this is the entire student SAT program, and hope you guys liked it. And we also have a community where once you join, you can join the community and you can ask. We will also be hosting live sessions. In that, if you have any doubts, you can always ask us and we will be guiding you. And you can follow the set of methods that we have given through the video. And if you encounter any difficulty, we are always there to help you out. And this is the student SAT program. I hope you guys are all interested to do it. Let's build a satellite and let's get it to space. Let us get all the data back from the satellite and do wonderful science with it. And hope you guys liked it. Thank you so much. And now I'm gonna hand it over to Ms. Shalini. Over to you, Shalini. Thank you. Yeah.
Thank you so much, sir, for the beautiful webinar.
Yes,
so
thank you.
everyone, students, I hope you have enjoyed the session and the webinar. So I hope everyone will be registering for the program. So if you are having any kind of queries, or else if you're having any doubts related to the program, you can feel free to call us, or else you can just check out our website, which is www.naso.in. So I'm just posting it in the chat box. You can just have a look of it. It's www.naso.in. And also I'm providing my mobile number. So for further communications, you can just call back, or else you can just ask your concerned coordinator who is dealing with the students at program from your school. So you can be in touch with Mr. Priyadarshan sir as well. So because sir is however available in the school. So whatever queries you can you're having, you just find out with Priyadarshan sir, or else just call to me. My number is given in the chat box. So thank you, students, everyone. Thank you for your attention for attending the webinar Beautiful Student Satellite Program. So I hope everyone will be registering for that. So once again, thank you, everyone. I'm ending the meet now.